Hello dear students, welcome to our YouTube channel Science GK Facts. And in the previous class, we already studied what is motion, what is rest, motion is relative and types of motion. We have covered all these topics along with basics in the previous video. And in this video, we are going to learn what is uniform and non-uniform motion, what is speed, what is velocity, what is average speed, what is average velocity, next what is acceleration. Along with this, we are also studying the differences between displacement and distance traveled. Okay, yes, let us come to the topic now. See, first let us learn what is uniform and non-uniform motion. What is uniform motion? If an object covers equal distances at equal intervals of time, then the object is said to be moving uniformly. Means what? See, equal distances at equal intervals of time means what? If you take one vehicle, if it starts moving, see, in first 2 minutes, if it covers 2 kilometers, in the next 2 minutes, again it has to cover 2 kilometers. Again in next 2 minutes, 2 kilometers it has to cover. Then we can say it is that vehicle is moving with uniform motion. Okay, its motion is said to be uniform. If you take, what is non-uniform motion? In first 2 minutes, a vehicle, it covers 2 kilometers, and in the next 2 minutes, it may cover 3 kilometers. Okay, and in the next 2 minutes, it may cover just 1 kilometer, and next 2 minutes, it may cover 7 kilometers. Here, what it is happening? Equal intervals of time we are taking, right? Everywhere, we are keeping the time intervals equal, but the distances covered in that equal intervals of time, it is not remaining same everywhere. It is changing. Okay, in first 2 minutes it is different, in the next 2 minutes it is different. So this type of motion, it is called what? Non-uniform motion. It is non-uniform motion it is. Okay, this is what? Uniform, non-uniform motion. Now let us come to know what is speed then. Speed is what? If any vehicle is moving, see, it covers certain distance, right? So, distance covered by that vehicle in a given time. For example, for 10 minutes if it is running, in 10 minutes how much distance it has covered? That gives its speed. Okay, so speed, how do we take? The distance covered by an object and time taken gives us what? Speed here. Okay, and distance traveled, it is denoted by S, and time taken by T, that is small t. Now, what is the SI unit of this distance traveled and the time taken, that is speed? What is that? It is meter per second, because distance traveled means it is length, right? What is SI unit of length? It is meter. What is SI unit of time? It is second. So meter per second it is giving. Next, coming to what is average speed then? Average speed, how do we take? Why do we take that? See, to measure the speed in the vehicles, there is on the dashboard, there is a meter, speedometer. In that speedometer, there will be one more small meter, that is called odometer. Odometer shows how much distance it has covered the vehicle, and that speedometer, and that one needle will be there. It will be moving here and there, and sometimes it will be digitally, it will be showing the numbers. See, that needle where it stands, for example, if it stands at 60 km per hour, the vehicle is moving with 60 km per hour. See, just you imagine, do we maintain the same type of speed to reach one place, from one place to another place if we are moving? To reach that other place, can we maintain the same speed? Is it possible in reality? It's not impossible at all. Okay, there is no possibility of maintaining the same speed because of what? Road humps, signals, traffic, animals, everything will be coming on the road. And in the beginning, the vehicle itself is at rest. Okay, it has to reach certain speed afterwards, right? So what happens? Its speed goes on varying throughout the way, throughout its journey. So what we are doing here? Speed means how we are taking total distance, how much it has covered, and total time, how much it has taken. Okay, the total distance taken by that vehicle, covered by that vehicle, and total time taken by that vehicle. That gives us what? Average speed. This is what? Average speed. Speed means we are taking into consideration average speed only. Okay, see, for example, if a vehicle travels from what it is moving from Dharwad to Belgaum, total distance is how much? 80 kilometers. How much it has covered total is 80 kilometers divided by how much total time it has taken. For example, if it has taken 2 hours, that 80 you have to divide by 2. how much you will get? That is 40 km per hour. Means what? That is the speed of that vehicle. Okay, this is how we can take that average speed. Average speed only we are considering everywhere. Speed means average speed itself it is. Next, coming to what is velocity. Velocity and speed, we need to understand the differences here. See, speed means what we took here? Total distance covered means average speed, or speed means distance covered divided by time taken we took, right? In velocity, what we are taking? We are not taking distance covered, we are taking displacement here. You see, displacement divided by time taken we are taking in terms of what? Velocity. What is displacement then? What is distance covered then? There is difference. You need to understand this first. Okay. Here, always if you take here from one point to another point, if a vehicle moves in a straight path, let us take in a straight path from A to B it is moving. Okay. Any object it is moving. Then what we can say, distance traveled is how much it is? Say for example it is 50 meter. Okay. We will write 50 meter now. 50 meter distance traveled. Now, if the vehicle is taking the curved path, say for example this is 100 meter. Now you see, in one case it is, if it is following the a straight path, it is 50 meter. If it is following the curved path, it is 100 meter. Okay. Distance traveled, it may be 100 or 50. Now, what is displacement then? Displacement means it is nothing but it is the shortest distance between the initial and final point of that moving object. See, initial point this is final point. What is the shortest distance? 50 meter only, right? So what we can write here? Displacement is 50 meter. Here you see, distance traveled, if it moves in the straight path only, then distance traveled will be 50 meter. Displacement is already 50 meter. Means what? Displacement and distance traveled both will be same when that vehicle moves from one point to another point. Okay, in the straight path. Okay. Next, coming to, if the vehicle after reaching point B, if it comes back to point A, you see, here this is also 100 meter you take, for example. Yeah, this curved path also. This also 100 meter. Total distance covered by that object is how much now? 200 meter. See, now it is 200 meter now. Okay. What is the displacement then? Now you see, displacement is what? Just 0. Because of what? Displacement is nothing but it is the shortest distance between the initial and final point of a moving object here. You see, this is initial point and final point means what? If it is stopping here, this will be final point. But it is continuing and coming back to the same position means what? Initial and final point are same here, A only. Then there is no difference between what? Initial and final point. Both are same here. So what we can say? Displacement becomes 0 here. Since initial and final point are coinciding with each other, what? Displacement is 0. But distance traveled is how much? 100 meter. This is 100 meter. Total 200 meter. So from this, what we can understand? Distance traveled, it can be greater than displacement, or distance traveled, it can be equal to displacement. These two cases we can understand from this. Okay. Distance traveled may be greater than displacement when it takes, leaving the straight path, if it takes other path, then it will be greater than displacement. But if the vehicle moves in a straight path, see here in this case from A to B, if it is moving, then what it becomes? D is equal to D also it becomes. Means what? Distance traveled or distance covered and displacement both will be same terms. Okay, same. But if the vehicle comes back to the same position again, then displacement becomes 0. See here, after reaching B, if it comes to same position, then displacement will be 0. Okay. Yes, this is what? Displacement and distance traveled. Now coming to speed and velocity differences first. Speed means it is a physical quantity which has no direction at all. For example, that bus was moving with the speed of 70 kilometers per hour, otherwise 80 kilometers per hour, we can say. But we are not saying, means we don't need to mention the direction there, from which position to which position. We are just concentrating on what? That physical quantity, that is magnitude of speed, only that much. Okay. But if you take velocity, in velocity we are taking direction here. Okay, displacement divided by time taken we have taken, right? Displacement means you can see here from this case only. From A to B if you are taking 50 kilometer or 50 meter, that is what a displacement. If you are taking again it from B to A, if you are taking, displacement will be 0 here now. See, so because of that, from which point to which point it matters here. So in terms of velocity we are taking what? Direction also we are taking. So this physical quantity, that is velocity, which contains both magnitude and direction, that is called what? Vector quantity. This speed, it carries only magnitude, no direction, that is scalar quantity. Velocity carries magnitude and direction both. So because of that, this physical quantity is called what? Vector quantity. Now you see, coming to next here, velocity over average velocity. Okay, and coming to the SI units, everywhere it is same. Here displacement, S stands for displacement again. Here distance covered, S stands for distance covered here. This is time again. What meter per second we have taken here? SI unit of this what? Speed is what? Meter per second, because distance covered is meter, time is what? Second. Distance covered is meter, why? It is length. Length is what? Meter. Okay. So meter per second. Here also it is same. In terms of what? Velocity also it is same. Okay. Next, coming to what is average velocity then? Average velocity is nothing but it is total displacement divided by total time taken. Okay. Average speed how we took? Total distance covered by total time we took. Right. Here total displacement divided by total time we can take. This is what? Average velocity. See, average velocity, total displacement divided by total time taken. Okay. Now, here speed we are not taking. Only speed we are not considering. In this lesson, we are taking this speed in terms of velocity only, because both magnitude and direction when we take, we can understand in more comprehensive way that one. Because of that, we are considering velocity only here. Okay, speed means. So that is why we are considering what? Here phi is equal to displacement divided by time taken we are taking. Okay, that is S by T we are taking. Now coming to what? Acceleration. What is acceleration then? Acceleration is nothing but it is the change in velocity divided by time taken, or the rate of change of velocity of an object is called what? Acceleration. The rate of change of velocity of an object means what? A vehicle starts moving. Say for example, if it starts moving, its velocity goes on changing. In the beginning it will be 0, later it attains 20 km, 40 km, 60 km, it goes on increasing or not there. Okay, again if it starts applying the brake, it comes down. Okay, so this is what? Change in velocity. This change in velocity how we are taking? Should we take 0 or should we take 80 km per hour? So we are taking this change in velocity by subtracting this initial velocity from the final velocity. For example, from the rest to it starts moving that vehicle. Say for example, up to 80 km is reached. In that 80 kilometers, what is speed? What we are velocity? We are subtracting its initial velocity. Initial velocity is what? It will be 0 because if it is at rest. So what we are taking? Final velocity minus initial velocity. When we subtract these two, what we are getting, that quantity, that is what? Change in velocity. In a given time, that change in velocity, how much it is there, this quantity gives us what? When we divide this change in velocity by time taken, what we are getting, that gives us what? Acceleration. That is acceleration. You see, phi minus u. Phi means what? What a final velocity. U means initial velocity, as I said, divided by time taken. See, T means time taken it is. You see, change in velocity divided by time taken, it gives us what? Acceleration. Then what is the SI unit of acceleration? Here it is written meter per second square. How we are getting this? You see here. First, change in velocity. Velocity is what is that SI unit? Meter per second, right? So meter per second. Down. Time what is having its SI unit is again second. Down again it is second. This can be written like this. M/s to the power minus 1 means meter per second. We can write. And down S again. Second is there. if you bring it to what a numerator, what it becomes? Again minus 1 it becomes. So meter per second into per second, when you multiply, you are getting meter per second square. Okay, according to laws of exponents. Okay, if you do this, what we are getting here is SI unit of acceleration, meter per second square. You have to be very much careful. Don't write meter per second whenever you calculate acceleration. Understood? I hope you all have understood this. What is speed, what is velocity, what is average velocity, what is average speed, and what is acceleration, uniform motion and non-uniform motion, and displacement and distance traveled. The differences you have understood well, I hope. If you understood well, so subscribe to the channel and share the video.